Hello, members of Mr. Aleynik's star quad group for all of his chemistry periods. I'm going to go to step 5 on page 3 of the differentiated quads worksheet and explain how to write in the electrons correctly for the Bohr model of calcium. So if we follow steps 1 and 2, we will remember that the atomic number is 20 because there are 20 protons, and 20 is the number that you see in the top left corner, the rectangle for calcium in the periodic table. The atomic mass is going to be 40.078 AMU. The number of protons will be 20, which matches the atomic number, and that will also be the number of electrons. The number of neutrons can be found by rounding the atomic mass to the nearest whole number, which would be 40. And then we're doing 40 minus 20 equals 20, which is the number of neutrons. Now, this is the hard part where people struggled a lot. So I'm going to do the electrons after I put these protons and neutrons in. So 20 protons, 20 neutrons. Now, the electrons are the hard part. So let's, all my students, please go to page 3, step 5A. So I'm going to read verbatim the instructions from the worksheet into this video so there's no confusion. All right, so step 5 says, watch video from Mr. Aleynik's YouTube channel, Common Sense Chemistry, here to learn how to write the electrons into the Bohr model correctly by following these steps. Step 5A, understand that the rings around the nucleus of calcium, which is the central circle with P equals and N equals in it, can hold different numbers of electrons. The smallest ring is right here, okay? This is the smallest ring, not this. This is the edge of the nucleus. This is the smallest ring, or energy level 1. This is the smallest ring, all right? The smallest ring can hold no more than 2 electrons, right? 2 x's on this ring. Okay, so for the purposes of this lesson, you can write the x's anywhere. We know that electrons repel each other, but the position of these x's doesn't matter. You can write this if you want so far, okay? So then, we're going to go to next part of step 5A. Keep track of how many electrons you have used and how many electrons you have left by subtracting 2 from 20. So after step 5A, we have 20 minus 2, 18 electrons, all right? So we're going to just make a note, 20 minus 2 equals 18 electrons. We got 18 electrons left to work with. All right, so for step 5B, write 8 x's on the ring that is second closest to the nucleus. Okay, this is the ring that is second closest to the nucleus. This can hold 8 x's. Each x represents an electron. 1, 2, 3, 4, 5, 6, 7, 8. In our future learning, you will learn that electrons are actually in these specific orbitals, which would be 2s2 and 2p6, but this is outside of the scope of today's lesson, so you can put these electrons anywhere as long as they're on this ring. They are a certain energy, and they're a certain distance away from the nucleus. This is the, the gist or the main idea of the Bohr model, all right? So we got 20 minus 2, which is 18. 18 minus 8, we got 10 electrons left. All right, let's go to step 5C. We're going to write 8 x's on the ring that is third closest to the nucleus. Keep track of how many electrons you have used and how many electrons you have left by subtracting 2 and then 8, and then 8 from 20. So after step 5C, we have 20 minus 2 minus 8 minus 8 equals 2 electrons left to use. All right, let's write in those x's. So we're going to write x, 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 x. All right, that's 8 more electrons that we used up. We got 20 minus 2 minus 8 minus 8. That is 20 minus 18. We got 2 electrons left. All right, so step 5D. Write 2 x's on the ring that is fourth closest to the nucleus. Keep track of how many electrons you have used and how many electrons you have left by subtracting 2 and then 8 and then 8 and then 2 from 20. So after step 5D, we have 20 minus 2 minus 8 minus 8 minus 2 equals 0 electrons left to use. All right, let's do that. 1, 2. Okay, so now, how many valence electrons do we have? Well, valence electrons are, by definition, the electrons that are farthest away from the nucleus or on the ring that is farthest away from the nucleus. So these 2 are our valence electrons. So we got 2 valence electrons, okay? 2 valence electrons, they're right here. These are our valence electrons. They're not just any electrons. They're the electrons that are farthest away from the nucleus. All right. Now, what this is asking us, energy levels, another way to ask this is, how many rings in this diagram contain X's or electrons in them? So we have one ring that has X's or electrons, two rings that has X's or electrons, three rings that has X's or electrons, and finally, four rings that have X's or electrons. So the total number of energy levels that we have that are filled with electrons or X's is 4. And this is how you would do all of the steps for the star quad of Mr. Aleynik's chemistry classes. Thank you and have a good rest of the day.